We are audio, so that's good. Share screen. I'm going to double check that the audio. Testing. Good. Okay, cool. All right, so just as a recap for everyone in class, virtual, those of you staying home, whatever your reason is for being in class or not being in class, everyone's responsible for these, okay? Last quiz, I had to give so many zeros or like 2 out of 10 or whatever because people didn't have theirs. And then by the time they opened it, they realized it was timed and they were like, well, I did not reopen it for them, okay? Because on my videos, like I went back and double checked, like on my videos, I repeatedly said, everyone needs these. You must have these, virtual or non. So the only thing I can assume is that those people that are quarantined or the people that are virtual did not watch the videos and they just got the information from their classmates. So I'm saying it again. This is going to be a quiz for literally every person that's in my class. If you're enrolled with geometry with Kristen Cole, you're taking this quiz, okay? If you're quarantined, if you're in class, out of class, staying home, football player, whatever you are, everybody's taking this quiz, okay? What you need for the quiz every day is the topic. And several of you got this one wrong. Of course, I went back and put the points in. But next time, it needs to be a capital P, capital L, the and sign, capital T, okay? If you wrote out the word A-N-D, it counted it wrong. If you lowercase the P, it counted it wrong, okay? Canvas is very picky on how they want the answers submitted. So make sure you write it down just like you see it. You need the date. Today is 11/16. You'll need that every time. Date and topic, and then everything on the screen. If you're virtual, I told them they didn't have to copy this or this, okay? Everything else needs to be copied word for word, even using the diagram, all of that. Everything needs to be copied, okay? Cool. No more F's on bell ringer quizzes. Bell ringer quizzes are supposed to be 100% A's, and there were hundreds, so make sure you're copying everything down. Okay, now for this, number 1, a plane that's parallel to QRZY. Anybody? PS, yeah, PSWX, okay? 3 segments parallel to RS. So here's RS. The segments are PQ, WZ, XY. Those are the 3 segments. Did you look up skew in your fancy cell phone that you use for texting in class? Look those stuff up. If you don't know it, Google it, okay? Skew means not parallel to, but also not touching, okay? So it cannot touch the segment, which this segment's PX. So it can't be PS, can't be Q, P, none of those, okay? So it cannot touch it, but it also is not parallel to it. So what would be a good example of that? WZ is a good example, okay? What's another one? YZ. Yep, SR, RQ. Those are the only ones it could be, those 4, okay? The other ones either touch it or are parallel to it, so those won't work, okay? So it can't be parallel, cannot touch the segment. Now, number 4 is totally like off to me because in order for us to have like corresponding angles, alternate interior angles, all those things require parallel lines. And does it look like you have parallel lines? I don't see parallel lines. But we're going to assume that they meant for lines L and M, this is L, this is M, to be parallel. And it just got a little crooked, okay, because we need to be able to finish this problem. So that's what we're going to go with. And I'm going to focus solely on these 8. because we can get everything we need from those 8. So that's what I'm going to focus on. So corresponding angles, I'm going to say 5 and 9. But it didn't have to be these, you guys. I'm just going to give you one example. Okay, 5 is here, 9 is there. They are both top left angle for their set of 4. Okay, then you have alternate interior. I'm going to say 6 and 10. This is just one example. Alternate exterior, I'll say 8 and 12. Okay, then we have consecutive interior angles. We didn't call it that. Springboard called it same side interior. Okay, same side, consecutive, that's the same thing. So I'm going to say 7 and 10. So same side interior. Vertical angles, there's like 1 million that you could choose from. I'm going to say 5 and 7. Any of them that touch on the nose are vertical angles, and then a linear pair is anything that forms a straight line. So I'm going to say 11 and 12. Those are just examples. Okay, so just examples of what could have been your answers. It needs to be one of those. Any questions about that? There are only 6 of these in this packet. So that means we'll do 4 of them this week. When we come back after Thanksgiving break, we'll do 2, and then on that Wednesday, we'll take the quiz. So you have to keep up with these over Thanksgiving break, okay? And this will be another quiz for you that should boost your grade as long as you're doing them, regardless of if you're in school or out of school. Everybody is doing these. All good? All right, we're back in our textbook. We'll be in our textbook all week long. And we are going to be on page 191. Page 191. If you didn't bring your textbook today, if you forgot that, then you're going to have to take your notes on a loose leaf sheet of paper and then transfer them to your book. I did not run these off for you, but you will need to bring your book every day this week, or at least activity 14. Anything that says 14, you'll want to bring 14-1, 14-2, 14-3. All of those is what we will focus on this week. So either carry that book around or tear out activity 14. Okay. Now, what all of these lessons are about, the whole activity 14 is about points of concurrency. Now, a point of concurrency is a place where the segments come together at a single point. There are different types of them. They'll have different names. I will teach you that as you go. This is probably not anything that you've ever done before. So this is going to be brand new information for everyone. So you need to be paying attention. You do have a quiz this week. You're taking your quiz on Friday. It's only 9 questions. So that will be something quick for you to do on Friday, and you can be done with my class for the weekend, for the holiday, okay? But in order for you to do well on that, you're really going to have to get these lessons, okay? So everybody's on 191. Josh, lose your earbud. Everybody needs their cell phones put up. Everybody needs to be with me, paying attention, no texting, on board. Got it? Okay, so our targets for today are to determine the point of concurrency, which if you don't know what that is, that's okay. We're going to learn of the altitudes of a triangle. Then we are going to use that point of concurrency of altitudes of a triangle to solve problems. Now, this whole activity 14 all plays on this one riddle, which I know is silly. I do know that, but we're gonna go with it. I'm gonna read it to you so that you can understand what's going on, because it will keep popping up over and over and over again. So I want you to at least hear the riddle, and then we'll get to the math, okay? So it says, Lucky Leon was an old gold miner whose hobby was mathematics. In his will, Leon left a parcel of land to be used as a nature preserve. The will included a map and the following clue to help find a buried treasure. At the point on this map where 2 altitudes cross, in a hole in the ground, some treasure was tossed. Stand at the place where the two medians meet, and the rest of the treasure will be under your feet, each locked in chest where they will stay until the time someone finds a way to open each lock with a combination using digits from the coordinates of each location. Okay, so we're going to be dealing with locations, specifically the location of an altitude where the two altitudes cross and the median. Okay, and once we have those locations, then we can use the digits of their coordinates to unlock the treasure. Okay, I realize this is silly and there is no treasure, but we're rolling with it. Okay, we're just going to have some fun and play along with their little game. If you look at the piece of land that Leon left us, you can see it is shaped like a triangle. Okay, which is what we're going to be dealing with. The triangle, the rest of this is water. We're dealing with this triangular piece of land. So if you go to the next page, they have graphed that piece of land on a coordinate grid for us. They've plotted out A, C, and G. So now we have triangle ACG, a good looking triangle. And we are going to start with the first part of the riddle. We are looking for where the two altitudes cross, okay? Now, what in the world is an altitude? Well, in your math terms, it tells you an altitude of a triangle is a segment from a vertex of the triangle perpendicular to the opposite side or a line containing the opposite side of a triangle. Okay, so starts at a vertex. What is a vertex? The A is a vertex. The C is a vertex. The G is a vertex. All of those are vertex. Okay, those are all vertex. So how many altitudes does this triangle have? 3, because it has 3 vertices or vertexes. Okay, so we're going to have 3 altitudes. We're going to come from each of those vertexes, and we're going to use the perpendicular slope of the opposite side. Now, everybody's like, how do you know what the opposite side is? Well, if I'm coming from A, the side will not include A. It's not AC, that's not opposite. It's not AG, that's not opposite. The opposite side is CG. It's across the triangle. It does not include the letter A, which is what we're coming from. So what we need to do first of all is if we're going to draw this altitude, the first thing that we need to know is what is the slope of CG? What is the slope of CG? How do you find the slope of a segment? Yeah, rise over run. Keep your life easy. Make it easy for yourself. Rise over run. If for whatever reason all they give you is some ordered pairs, then you could do this. But if you've got a graph, count, rise over run. So what would you have to do for G to get to C? Rise what? So you're saying down 1, right 1, down 1, right 1, down 1, right 1. Does that work? Yeah, or up 1, left 1, up 1, left 1, up 1, left 1. Either one, down 1, right 1, or up 1, left 1. What's that going to give us for the slope of CG? -1. Okay, well, we don't actually need that slope. We need the perpendicular slope. How do you find perpendicular slope? The opposite reciprocal. So not only do we want the opposite, we want the opposite reciprocal, which of -1 is going to be what? positive 1. No 2. There's not a 2. So just 1 over 1. So you're just flipping those ones. 1 over 1 just stays 1 over 1. The only difference is now it's going to be positive. So I'm kind of skipping around with what the book has in their order, and we're starting with one thing. We are going to draw the altitude from A to CG. So we're starting at A, and we are using the slope 1 over 1, which just looks like a giant plus sign. 1 over 1. So from A, I'm going up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And I'm continuing this because we are looking for a specific location. So I need my graph to be very precise and very accurate. So draw your dots, use your slope, rise and run to get yourself a very good line. I'm going to even use my line tool to make sure I have a straight line from A through CG. And I know it's perpendicular because I use the perpendicular slope. So I'm going to put my box right there, which shows that it's perpendicular to that segment. Any questions on how I just did that altitude? What you just did is the altitude. You went from A, you used the perpendicular slope. That's an altitude. Questions? That is the altitude. That segment is the altitude. Yes. Yep. Now let's do the altitude from, let's do C. Let's go from C and draw the altitude. So what slope do we need before we can draw this altitude? Good. We need the slope of AG. So how are we going to find the slope of AG? You can look at the rise or the run, but this one is just a flat line that is horizontal. What are all flat horizontal lines? 0. 0 slope. Think of a treadmill. That person is walking on that treadmill at a slope of 0. Okay? All right, so we've got our 0 slope. So what is the perpendicular slope to a 0 slope? Nope. Undefined. Okay, so undefined slope looks like what? That's right. It's a vertical line, straight up and down. Now, you cannot draw that straight up and down line wherever you want. It has to connect with C. So when you take your straight edge, line your straight edge up with C and draw a vertical line. Again, we are trying to be very precise because we are looking for the point of concurrency, and that's going to be where all of these altitudes cross each other. You just drew an altitude. It is perpendicular, so you can put your right angle box. Okay, it's perpendicular to that line at the bottom. Now we have 2 altitudes drawn. Now, who's left? Okay, we're going from which vertex? G, so I need to know AC's slope. What is AC's slope? Okay, positive 2, so up 2, right 1. Hold on, y'all, let me answer this. Hello. Hey. we need the perpendicular slope of AC. AC's slope is 2 over 1 or 2. So what slope do we need to use? Negative 1/2. We want it to be opposite, so negative, and we need to flip it for the reciprocal, so that's 1/2. So from G, I do not want to go down 1, right 2, down 1, right 2. So what am I going to do? That's right, up 1, left 2, because that's still going to give us the negative effect. So from G, I'm going up 1, left 2, up 1, left 2, up 1, left 2, on and on until I can get across that triangle. Again, you're using your straight edge. You want it to be very precise, very straight, and ta-da. Now, you'll notice that all 3 altitudes meet in one place. Where is that one place? That's right. They meet right here at 12. We're counting by 2s, 10, 12, 14, 16, 18, 20. So we're counting by 2s. So that is at 12, 12. Okay. It is called the point of concurrency, and you can see that on number 4. If you look at number 4, it says, after drawing the altitudes, Jeff was surprised to see that all 3 altitudes meet at one point. State the coordinates of the point of concurrency. So what is the point of concurrency? 12, 12. So for number 4, you're writing 12, 12 as your answer. But then I want you to go directly over to page 193 at the bottom. It says at number 10, the first part of the buried treasure is located at the orthocenter, okay, of the triangle. So what is an orthocenter? We'll look in the box that's right beside it. The point of concurrency of the altitudes of the triangle is called the orthocenter. We're going to be learning about medians and altitudes and all kind of different things. So this one is specifically named an orthocenter. So the point where your altitudes meet up is called the orthocenter. Well, point of concurrency can be several different things where the medians meet, where the altitudes meet, where all the different segments meet up. But orthocenter is specifically for altitudes. So this is an orthocenter, and it is specifically for your altitudes. Tomorrow we're going to learn about medians. Medians will also have a point of concurrency, but it's not called the orthocenter. So orthocenter is specifically named for the point of concurrency of altitudes. An altitude is when you come from the vertex of a triangle and you use the perpendicular slope of the opposite segment. Okay? From the vertex, using the perpendicular slope of the opposite segment. Questions on how to draw an altitude. What's it called? The orthocenter. Okay, where all of those altitudes come together is the orthocenter. Now, orthocenters don't necessarily have to be inside the triangle. They can be, like this one, but it doesn't have to be. We'll learn that as these lessons go on, but if you're doing your work and you see that it's outside of the triangle, that doesn't mean that you messed up. Okay, it is possible for it to be outside of the triangle. Keep doing what you know to do. Use the opposite slope with the vertex. Okay, now, not only are we responsible for drawing these, they also want us to be able to write our algebraic equations. So when you write algebraic equations, you're doing that exactly like you did back in Algebra 1. Okay, so depending on who your Algebra 1 teacher was, there are different ways to do this. But if you had Miss Dean and you did Springboard, then you should be familiar with the point slope form. So point slope form is what we can use when we have a given point and a slope. You guys just identified all the slopes for me. You told me what the slopes were going to be. You said this one's slope is 1/2, this one is our negative 1/2, this one is 1, and this one's undefined. So you already gave me the slopes. You know the slopes. You also know the points because you can use the actual vertex. Okay, so where is A located? 0, 0. Where is C located? Where is G located? So you can use those ordered pairs. You've got an ordered pair and you have a slope, so you can write an equation. Okay, so that's what we're going to be doing. Now, it does give us this helpful hint and tell us that the horizontal lines are going to be y equals a number. The vertical lines are going to be x equals a number. So those may be possibilities that show up. So if they do, you've got that to go back and reference to. So we are going to start with B. We're going to write the equation of the altitude from A to CG. So I need A's ordered pair. What's A's ordered pair? 0, 0. What's the slope that we used to get to CG? Was it 2 or negative 1/2? I don't remember. Let me look just to make sure we're right. No. From A, what was the slope we used from A to get to CG? Look at your slope. 1/1. Okay, so if you go back and look at your actual graph, we used 1/1 because the slope of CG is -1. So slope of CG is -1. Well, we're using the opposite reciprocal, which is going to be +1. Okay, so then when you write your equation, you do y minus y1 equals mx minus x1. Hopefully, this is a review for you of Algebra 1. So we take the x1 and we plug it in for x1. We take the y1 and we plug it in for y1. And we take the slope and we plug it in for the slope. Those are the 3 places that you have to plug them in. I color-coded them for you. The y that's green and the x that is green stays. It's part of the equation. So it's going to be y minus, what's y1? Good, 0 equals what's the slope? 1, x minus, what's x1? 0. Cool. So you got it plugged in. Once you have it plugged in, then you just have to simplify. What is going to be your first step in simplifying these? Good, distributive property. What's 1 times x? 1x or just x? What's 1 times -0? -0, which I'm not even going to write because it doesn't do me anything. And then on this side, I have y minus 0, so what's really over there? So this equation is just y equals x. Okay? Now, the next one is from C to AG. Okay? So from C to AG, this is the one we're looking at, this one. So what's C's ordered pair? 12, 24. What is the slope of AG down here? It's 0. So what's your slope going to be? Now, can we do y minus y1 for something like this? No, because you have a vertical line, which they told us vertical lines are going to be x equals a number. So what is x going to equal in this triangle's case? Good, 12, because it crosses down here at 12. So it's going to be x equals 12. So we have two of the three handled. We've got the one from A, we've got the one from C. Now let's do the one from G. Okay, so what's the ordered pair for G? The ordered pair. Good, 36, 0 is my ordered pair, and then the slope that we used is, that one's -1/2. So that's the slope that we use because AC's slope is +2. So we wanted the opposite reciprocal, which is why we have -1/2. Everybody okay with that? Write your equation. Y minus Y1 equals M, X minus X1. So what's Y1? 0. What's the slope? And what's X1? Perfect. Okay. Plug in all the pieces, get them all in the right spots, and then you're ready to simplify. So I start by distributing. What's -1/2 times X? What's -1/2 times -36? +18. Again, Y minus 0 is nothing for me, so I'm just going to write Y equals -1/2 X plus 18. And that one is the most comfortable for us to look at because it looks normal. Like you can see 18 is the y-intercept. You can see the slope is -1/2. So that one's more like what we are comfortable with. Now, if you're given the equations of the altitudes, like if let's just say start over and they tell you, here's the equations of the altitudes. Find the point of concurrency. Well, you don't have a graph. All you've got is the equations. So what you're dealing with, though, is a system of equations because you've got more than one, right? Think back to Algebra 1, system of equations, more than one equation. So we're dealing with a system of equations. How can we solve a system of equations? Good. Number 1 is graph. Number 2 is the substitution method. And then what's number 3? Elimination. So you already know how to do this, or at least fingers crossed you know how to do this, because you should know how to do substitution, elimination, and graphing. Okay, so what you're looking for is that point of intersection. That's going to be your point of concurrency. So they've told you what they want you to do. On number 6, they say, use the equations from the altitude from point A and point C. So that's going to be B and C. So if we're looking at this as equation 1, and you're looking at this as equation 2, what method are you going to choose? Graphing, substitution, or elimination? You could use graphing if you wanted to. We're going to pretend that's not an option since we already did that. So out of substitution and elimination, which one's going to be the easiest? Definitely substitution, because you can't eliminate in this case because equation number 2 doesn't have a y. So there's no way for us to stack them up. So you have to use substitution. Who's substituting into the other one? Substitute 2 into 1. So we're substituting equation 2 into equation 1. So now equation 1 is going to say y equals, instead of, I forgot my 1. Instead of x, what are we substituting in for x? 12. So this is a very basic substitution equation, or system of equations. So what's my solution going to be based on what we just found out? What does x equal? 12. What's y equal? So what's your solution? Isn't that exactly what we found through graphing? Didn't we find out it was going to be at 12, 12? Yes. So the system of equations using substitution worked. Now, do I have to do that again using D? You definitely can. You could say equation 1 this time is going to be x equals 12. And equation 2 is going to be y equals negative 1/3 x plus 18. And again, you would choose. Do you want to do substitution or do you want to do elimination? What would you choose? Substitution. And you would just simply sub in 12. And that's going to give you your y. What's negative 1/2 times 12? What's negative 6 plus 18? So y equals 12. Is that what we think it's going to be? Yes. So that system of equations, all three of these, has the same solution, and that solution is 12, 12. Got it? For those of you that have Miss Castleman or Miss Panos, you've already done systems of equations with 3 equations. You could set this up as a 3 equation. The only difference is this doesn't have a z. So the ones that Miss Castleman and Miss Panos did, they had x, y, and z, x, y, and z, x, y, and z. Okay, this is not going to have all of that. This just has an x and a y and x and a y. So it's not going to be as difficult as the ones that they taught you, but it's on the same basic premises. Okay, so this is like marrying algebra and geometry together in this lesson. So we're able to do these altitudes, but these altitudes have an equation because they are a linear segment. So they work just like a linear equation with systems of equations. What's the point called where they all come together? That's an orthocenter. Okay, and that is specific for altitudes. So to recap, rewind and recap, an altitude is part of a triangle. Okay, it's a way that we can find a specific, location within or around a triangle using its vertices, the vertex, and the slope that is perpendicular to the opposite segment. Okay, the one that is away from the vertice. When you graph those out, they're going to come together at a single point that we call the orthocenter. Got it? Do you have any questions for me? Your homework is on page 194. Okay, so homework is page 194. You are doing 13 and 14. Those graphs are there for you. You're going to be finding the orthocenters. Graph your altitudes. Find the orthocenter for those 2 problems. Okay. Now, for the canned food drive, don't forget that you have to have your canned foods in this week. Do not depend on when you come back from Thanksgiving. They need to be in this week. These points, what everything is point-wise, is on Canvas. Y'all, an individual serving of mac and cheese, one of those personal cups, okay, that's only 1 point because that's an individual serving. The box of mac and cheese, that's worth 2 points. Okay, so that did come up. That question's been brought up. I want that stuff before you leave. People have asked if they can bring it up on Friday. I will be here on Friday, so if that's when you want to bring it up, that's totally fine with me. Any other questions for me? Y'all are awesome.